All right, so here is the last exercise that we have in the arrays section. So basically what we have here is we're told that we have an array of length 10 and it starts out, or length n, and here it's 10, and you start out with instructions of how to increase this array. So basically we have these triples that were given, and these sort of tell us what to do to the array. So this 153 tells us that in entries 1 through 5 of this array, we want to add the number 3. And so that's sort of what's shown down here, is that we see we've taken this array and we've increased entries 1 through 5 by 3. And of course, they decided here to have their indexes start at 1, whereas in Python it starts at 0. And so we see immediately that we're going to have off by 1 headaches that we're going to have to deal with, but that's sort of something that you just have to deal with. So anyways, moving on. So 487, that means between indices 4 and 8, we'll add the number 7. And so here, entries 4 and 5 have gone up to 10, and then 6, 7, and 8 only go up to 7. And then you go and you continue on. And at the end, you want, what they're asking for is the largest value in this final array. So let's just imagine that we sort of do this in the exact way that they've described here, which shouldn't work because the difficulty is hard, but let's just imagine that this is what we're going to do. So we would say sums equals, now one way we can define this is 0 for I in range n. So this is just going to be an array of length n of zeros. So then for I in however many queries we have, that's not how you spell len. So for each instruction, so for I in the length of queries, basically we're going through each of the triples. So for each triple, we have to go through all of the indices and sums, and if basically this index is in the specific range, then we need to increase it. So if queries I0 minus 1 is less than or equal to j, and j is less than or equal to queries I1 minus 1, then we're going to take the jth column and add queries I2. Because remember, index 2 of queries I tells you how much to increase each index by. And the indices that you need to increase are given by, let's see here, the smallest index is queries I0, and the largest is queries I1. So for any index between these two, we want to increase it. And of course I had to subtract 1 here because, like I said, the indices were off at the very beginning. And so then we return the maximum value in this array sums. So let's go ahead and run this and see what happens. Yeah, it looks good. It gives you the largest one. And so then let's try submitting this code and see what happens. All right, so it seems to be working. And then there's some waiting time, and so this should sort of raise some red flags in your head, like, and then definitely the red X's should raise some red flags. And so if you look at these, you see time limit exceeded in all of these. And that sort of makes sense because if we look at this, the lengths of the arrays and the number of instructions given can be quite large. So we need to think of a really efficient way to do this. And so one thing to think is that, well, if you look at each of these instructions, there's only 3 pieces of information here. Whereas in this step here, in order to actually account, in order to take each of these different instructions into account into the final array, we need to do a lot of things. We need to do n things. Or if you skip over the ones where j is not in the correct index range. In fact, what I'm seeing here, one way that we could make this easier if we just wanted to keep with this was, instead of doing range n, we just specify the range to be here, and then we want to go up to here because of the -1. Let's just try this. I know this is not going to be good enough. But I'm just curious about this. Okay, so yeah, it seems to work. So I surprisingly didn't do an off by 1 error. And we're still having issues. Okay, so we have a pretty good idea that this is not going to work. Oh, it's actually working for some of these cases. But yeah, it's still going to time out. Okay, so anyways, back to what I was saying in terms of what we really need to take into account. So the fact that each instruction has a small amount of information means that we want to sort of try to take advantage of that. We want to see if there's some way to store like as little information as possible in each of these steps. And so if you think about it, so if you've got this function, let's consider this, let's consider each of these instructions as a function. So you can imagine this as a, function. Basically, this is an array where we've got 3s from index 1 to 5. So if you're just looking at what the actual values are of this array, then there's sort of information in 5 separate entries of this array. However, we see there's only 2 possible values in this array. It's either going to be 3 or it's going to be 0. So let's see if we can try to think of how we can use that to our advantage. So the first value here is going to be 3, and then the only other change here is when we go from 3 to 0. So basically what's happening is we've got this first instruction here, 1. So starting at entry 1, all the values to the right of that are going to be 3 larger than the values to the left. And then similarly, once we get up to 5, all the values in this array to the right of entry 5 are going to be 3 less than those in entry 5. So basically what we could think of is we could imagine like an invisible 0 on the left here. And let's think of what if we stored not the value in this array, but how this value compares to the value in the entry to the left. So here, this 3 is going to be 3 more than this sort of imaginary 0 at the beginning here. So we would put a 3 here. Then here, well, it's still 3, so we've changed by 0. So it's 0. Here again, we're at 3, 0. Here we're at 3, 0. Here we're at 3, 0. Here we've gone down from 3 to 0. So we've gone down by 3. So here we could store a -3. And then here, of course, we're not changing at all. So that's still 0, here 0, here 0, here 0. So if we track not what the value in this array is, what the values in this array are, but instead how each value compares to the value to the left, then only 2 of those entries are going to be non-zero. So there's a lot of, we can store a lot of information that way. And so one way to think about that is that's sort of like taking the derivative. We're sort of going to, we sort of want to keep track not of the array itself, but sort of like of its derivative in some sense. But the idea here is that we could do the same thing for the other instructions. So here, when we have 4, 8, 7, so entry 4 is going to be 7 greater than entry 3, and entry 9 is going to be 7 less than entry 8. And so you can think of this like the derivative for this sort of in the sort of quote-unquote derivative for this instruction 487, you would have a positive 7 in entry 4 and a negative 7 in entry 9. And of course with derivatives, they're additive. So if you want the instructions for how this array looks right here with the 3s, the 10s, and the 7s, you could just take those previous two instructions and add them together. So we'd have a +3, a +7, a -3, and a -7 here. So that's only 4 pieces of information. So with each instruction, you only add 2 pieces of information. So that saves a lot of time. And then at the end, what you can do is you can recover what the final array should look like by going through how each entry compares to the previous one and just adding it cumulatively. So if you just, if your array looks like 3, 0, 0, 7, 0, -3, 0, 0, -7, 0, then here the value in this entry, well, you've got a 3, and so you keep it there. Then for this entry, so you take the previous entry, which was 3, and then you add the entry here, which would be 0, and then you stay with 3. And this will make more sense when I actually write it out. But essentially what we're doing at the end here is we're just integrating it. So anyways, let's actually write out what this looks like. And let's see here, I did not come up with the solution, so I'll go ahead and give credit. So this, we've actually used this commenter before, so they seem to be someone who not only does a good job of giving good solutions in the comment section, Python 3 solutions, but also a really good job of explaining their reasoning, and they do a really good job for this one as well. So you can look at the comment if you want, but that's also sort of what I'm trying to do here. Okay, so here we're going to have our array, and we're going to start out with a bunch of zeros. And here, this is just another way to define an array. Notice that this is going to be of length n+1, and the reason that we need to do that is, remember, so here when we were talking about like 1, 5, 3, so when we track the derivative, we put a +3 in entry 1, and we put a -3 not in entry 5, but in entry 6. So we do need, so for example, if this were 1, 10, 3, then we would put a +3 in entry 1 and a -3 in entry 11. So we do need an additional entry here, but of course that's never going to impact the maximum, because there can only be a possible negative entry in the n+1 place. Okay, so we have this, and then for each, so for query in queries, so basically what this is going to do, queries is a list of, or a collection of triples. And so each query is going to be one of the triples. So A, which is a starting point, is going to be the first entry, query 0. And we have to subtract 1 again because we need to make sure that the indices are aligned like we talked about before. B is going to be query 1, which is the endpoint. And we don't subtract 1 because, again, this needs to be one index to the right, but because the indices are already shifted, those shifts sort of cancel each other out. So K, then the value that we're actually adding is going to be query 2. And then so array, again, this array is the derivative. So in index A, we're going to put K, and in index B, we're going to subtract K. And then here, so the maximum value, which is what we're looking for, is going to be 0. And the running count, which is basically going to be the integral the integral of the array called array. It's going to be the actual value in the final resulting array, and these are going to be the ones that we want to look amongst to find the maximum value. Okay, so then for I in array, so for each entry, the running count, we're going to increase it by whatever this derivative is. So this could increase the running count, this could decrease the running count, depending on if this particular value in array is positive or negative. Or it could stay the same, it could be 0. And then if we've increased, if the running count has increased enough to where it's beyond the max value, then max value is going to be, we're going to set it to running count. And then we're going to return the max value. All right, so let's just sort of run this to see how it works. So what I'm going to do is I'm going to print each query, and then I'm going to print array here. So this is going to keep track of what array is doing. And then here what we're going to do is we're going to, let's go ahead and print running count so we can sort of see how we go from array to the final values. All right, so let's see what this looks like. Okay, so we start with 1, 2, and 100. So entry 1 is going to be 100 more than what we started with, which we started at 0. And then 2 is also going to be 100. Then starting at 3, we're no longer adding 100, so we go down from there. So it's going to be minus 100. And then 2, 5, 100. So at entry 2, we're going to go up by 100 again. And then after, so then we're going to stay up there at 100 until index, until index 5. So that goes up to here. And then after that, we drop off. So that's going to be minus 100. And again, this is outside of the range of the array, but it doesn't matter because there's a negative value here. And then here, 3 and 4, we're going to increase by 100 again. So 1, 2, 3. So this, we're going to go up by 100 here, and that cancels out with the minus 100, so we get 0. And then we're going to stay there for 4, and then we're going to drop off again here. So that's going to be minus 100. All right, so this is the derivative of what the final array will look like. And so to look at what the entries of the final array look like, this is the running count value. So we start at 100, that's the first value here. Then we increase by this 100 to get 200. Then we increase by 0 to get 200. Again, 0 to get 200. And then here we have negative 100, so it's going to go down by 100. And here we have negative 100 again, so we're going to go down to 0. So actually, at the end, we should always end at 0. So if we wanted to optimize it a little bit, we didn't have to go through for I in array. We could have gone for I in array minus the final index, but whatever. It's not going to say. It's not worth the time savings, in my opinion. And so there we go. And basically what the code would do is it would say, it would start with this 100 and say, okay, well, that's greater than 0, so that's going to be our new max value. Then here it's like, oh, 200, that's larger, so that's going to be our new max value. And then all of these other values don't really matter because none of them are above 200, and so our final output is going to be 200, and that's what we got here. All right, so this seems to work. Let's go ahead and submit the code and see if we've optimized it enough to make it, ooh. It didn't. Oh, maybe that's because I'm printing things. Wrong answer. Well, that seems weird. Let's try this again. Oh, all right. Well, I guess, Yeah, maybe when you print things, like there's a limit to how many things you can print, and at some point it just returns like something that you've printed. I don't know. I just made that up right now. That's probably not correct because, or if it is correct, then it's not based in fact because it's just a guess. But anyways, so yeah, when you're submitting this, it's definitely include print values in your function as you're in your code as you're writing it to help it's to help you see sort of what's going on and what the code's doing and everything. But then once you actually have the final code and everything, just get rid of all of that. And so yeah, again, so I didn't come up with this code or anything, but I at least hope I've done a good job of explaining the idea of how you would come up with this code in the first place and how you would implement it and sort of why this is the best way to solve this problem. But yeah, that's about it for this problem. And so I guess there was really only that one problem in the array section where we ended up using dictionaries. All these other ones, it's really just, so this is, I really like this in that this is not about like, you can solve this problem using arrays. The real trick here is understanding how to solve or how to optimize the process of finding the solution, rather than the trick being some fancy coding knowledge that you need to have, like special instructions. There's no like fancy instructions here. It's really just sort of a clever implementation. But anyways, that's how you go about solving this problem. And that wraps up the array section.